very much for coming this evening. I hope you enjoyed the tour. I recognise a lot of faces, and you'll know some of the tour better than we do soon. Having said that, the nice thing about this museum is every other month it changes and something new. So within a couple of months there'll be new galleries open as well. So it's always worth repeating the tour. Firstly, can I thank Simon Paisley at SNP for supper this evening.
Simon's right there. So thank you, Simon.
I'm pretty sure I haven't been there, but I suspect it's not all gone either. So please help yourself at the end. Also, SNP have bought some of the modern kit that we can see around.
The new stuff.
Absolutely, I mean, glorious stuff. I couldn't. There was nobody else in here, and I couldn't resist pressing as many buttons as I could over there. I didn't get anything to change at all. I'm disappointed. Also, I'm thanking people, it's John, Chris, and Jim for the lighting and for recording this event as well. We haven't done this before, actually. This is such a good idea to actually record these lectures, so I hope we can do that again in the future. Rob Halliday is with us this evening. Rob's well known in this industry. We're very lucky to have him actually talking this evening and to have brought so much kit and colleagues with him. So I'm really quite looking forward to it. My very limited experience of lighting goes back to amateur dramatics and a rank grandmaster, which involved some effort, some serious effort, and actually operating on your own was hard work. And if you gained a few more legs and a few more arms, that would seriously help. And then I haven't seen anything since, so I'm really quite looking forward to this. Again, thank you very much for supporting this, and I hope we will see you again at the museum. But in the meantime, just as he sits down, over to Rob.
Thank you. Thank you. I'm just going to thank you back, but that tour was amazing. That collection of stuff in there is kind of amazing. So let's round of applause. So this is like a slightly odd crowd. I haven't quite figured out how to pitch to this crowd. Because quite often I talk to students about this, and if I make like 4,000 glaring factual errors, it doesn't really matter because none of them know. Whereas some of the people in this room invented quite a lot of this stuff. So I hope they're just going to be very polite and sit quietly and beat me up later. My background to this, because there must be a reason that I have some justification to sit here and talk about this, is I use these machines now. I'm now this job that has ended up with this title of lighting programmer, which is a very pretentious sounding thing for the person who used to be called the board operator, the person who used to run the control that controlled the lighting. That's what I do now, but I also have this obsession for some reason with old technology, so I write about it for one of the trade magazines, a thing called Classic Gear, which is in Lighting Sound International every month. And I'm also have become involved with this thing we're trying to set up called the Backstage Heritage Collection, which is ideally would be a museum just like this, but full of lighting stuff. And not just lighting, actually backstage stuff, lighting and sound and staging technology. But we haven't quite figured out how to do that yet, so we might be coming for advice. Or maybe some of this stuff, the computer stuff, maybe it could end up here, just saying. So I'm a bit humbled to be speaking in these people's presence, but this is my normal working environment now. So in a theatre with some kind of computerised lighting control, with some kind of show happening in front of me. That was Miss Saigon, this is Mary Poppins a few years ago. This is what our working environment looks like. This is what theatres look like when you're not there. This is the pile of people and desks and paperwork and computers now for every department that we now need to make a show. Arguably we don't need, but we'd like to have. It's like a comfort blanket, I think. So the key point is, what happens when you put a bunch of lighting-y people in the room together is it becomes very hard to talk about the art of lighting, and everybody starts talking about technology. And that's fine, except the reason that we have all this technology is actually to do lighting. You know, that's what we're there to do, and the tools we've made and have been created and we've used over the years are there to help us do lighting. And that really sounds like it should be the simplest thing in the world. You know, it's turning lights on and off. You can do that with a light switch in your bedroom. What complicates it in the entertainment world is scale because we have a lot of lights. It's dynamic because we like lights that change, and they will help guide you through a performance or change your reaction to a performance. And also when we're making it, it's by the pressure of making lighting in like a pressure pot world of showbiz, because everything else in a show can get made in advance. You know, the actors will spend weeks in a rehearsal room rehearsing. The set designer will build little models that then will get turned into bigger models that then will get built as full-size scenery. Everybody has plenty of time to say, I don't like that colour of pink. Could it be a slightly different shade of pink? Lighting, with sort of exceptions we'll look at later, really can't happen until you get into the space. And at that point, probably on a small show, you've got 3 days from when you go into the theatre to when an audience show up. And so you are now creating your work live in front of everybody else who's been thinking about it for months. And even if you've been explaining it to them for months, what you're going to do, it's almost certain they haven't understood a word of it. And the first time you turn a light on, they're going to go, oh, green. Oh, I know you said green, but I thought you meant blue. And then you need to figure out how to do something about that really quickly. Also, what we do isn't illumination. You know, illumination is turning on lights to see, and that's part of what we do. But what we also do is, this sounds terribly pretentious, but it's we create the actual magic. A light designer I work with, called David Hersey, calls it lighting is the glue that sticks a performance together. It's the thing that binds everything together. So it's what can take a space like this, an ordinary fluorescent light lit, white, harsh space, and if the performance needs it, it can turn it into that. The only thing that's changed there is the lighting. It can't necessarily be about illumination, because the illumination might be not seeing the people, it might be creating an atmosphere around them. That's Les Miserables. It might be manipulating the audience. This is one of my favourite cues I've ever done. This is My Fair Lady, the Eliza walking on in the ballroom dress for the first time, and if you got the lighting right, you heard the audience gasp, and the lighting had created that reaction. And that's caused by this light here. And we proved it by accident one night because that light there didn't work. The bulb had blown and the audience didn't gasp. Controlling space and telling you where to look. That's Shakespeare in Love. Defining a space and just changing it by light. So in all these shots, which is Equus, the only thing changing is the lighting. Nothing else is changing apart from the actors moving around a bit. There's a play called Lear, written by a playwright called Edward Bond, which was lit by a light designer called Andy Phillips, who was famous for white light, not using the rejection of colour. And in Lear, his eyes get put out. And Edward Bond talks about the play, talks about working with Andy Phillips, and he said, he told me he lit the whites of their eyes, which is what Phillips was famous for. So I wondered what would happen, what he would do when Lear's eyes were taken out. And he says, what Phillips seemed to do was concentrate light on the hands. Uncannily, I became aware of Lear's fingernails. What we're doing is we are controlling the space and what you see and how you see it in ways that you, as an audience, might not even be aware of. Except if it wasn't there, your experience of the play would be very different. Mary Poppins, a fabulous piece of scenery, which Howard Eaton, who's sitting here, built, did the lighting for. Again, transforming space. The only thing that's changing here again is the lighting. But the mood becomes very different. This is Henry V last year. Crazy example of a play that is normally set in a living room made surreal, which was Inspector Calls 20 years ago. This is the play Red, which you saw as the room transform earlier. This is a play I lit, which I just like because it feels like a painting, but it's all done with light, because painting is really all about light as well. It goes beyond theatre now. Art exhibits are just about light. This is at the Tate 10 years ago. We transform buildings now. This is the Empire State Building in New York. Howard does a lot of the things you see. These rings were Howard as well, actually. Transforming an entire stadium and launching an international sports event is all about lighting. This is really interesting because after this I heard I don't know the polite way of putting this, but a slightly elderly lady and gentleman on the train one day talking to somebody about the Olympics and saying their favourite thing about the opening ceremony was the lighting. And they really had no understanding of what they meant by that, but they'd been moved by it. Concerts, what brings the audience to the feet at the end of the show is lighting. And now with video, we take light further and we can completely transform an entire space. We can become the scenery. To do all that, we need to control the light. That's the problem. It's a relatively new problem, just to digress for a minute, but it's a relatively new problem because we didn't used to worry about it because the lighting used to come from the big giant light in the sky. And we used to take advantage of it by doing shows outside, particularly if we lived in warmer countries than maybe we do here. Which is fine until the rains came, and then it wasn't quite such a fun theatrical experience anymore. So then we moved inside, and when we moved inside, we started finding that we could manipulate the natural light in interesting ways. Churches are a prime example of this, because they take colour and add it to the daylight, and suddenly you're in a completely different environment, a magical environment in a way. Once the sun went down, we had a bit more of a problem. So now we had to start inventing ways to illuminate our performance so that you can actually see, and it's not just like some kind of crazy radio play. Candlelight was one of the earliest ways, which is the flame from the sun in a more localised form. Weirdly, it's making a comeback now. There's the Wanamaker Playhouse in London, and there's another one in America where they're starting to do performances lit by candlelight again, because everything that's old eventually comes round again. But it would start to be what I would consider the process of designing lighting. Somebody saying that I can have these flames, but maybe if I put a piece of coloured glass in front of it, I can change the mood of the scene by making it a different colour. Rather than necessarily just the engineering of, do we have enough candles to make it bright enough to see everything? The only problem with the candle is you can't really control it very well. If you want to turn them out during a show, the only way to do that is to have somebody going along going unless, again, you're Howard Eaton. This is the thing we built last year, which is 300 real candles. So I didn't mean this to be like your PR pitch. A lot of candles. These are real candles with little tiny CO2 jets going into them, so that on cue they could be blown out by the craziness of whatever. It's kind of an amazing effect. Except it was too good. Nobody believed they were real candles, actually, was the net problem with that. Candlelight also, interestingly, defined the shape of drama, because acts of plays would be constructed around the length of time that the candles would burn before they were worn out and you had to replace them. Creative people are interesting because once they decide they like something, they like the effect of this lighting, mere practical problems tend not to get in their way. So they would go and try and find other ways to achieve what they wanted to achieve. And the next way they found was gaslight, which they could start to control remotely because you control the flow of gas to the burner. So the man over here has a little panel of controls, dials to turn lighting up and down. Jim Laws, who's here somewhere. So with students I play, hey, guess what this is, but we haven't got time for all that nonsense. So this is a gas lighting control. And what's really interesting about it is the things you need to do to let us do the crazy things we need to do for lighting. So the problem with gas is if you fade all the lights out, how do you get them to come back on again? Because if all the flames have gone out, when you turn it back on, probably you're going to be one of the next theatres to burn down or explode, which happened a lot with gas. So the little tiny taps here let you set a minimum flow of gas so that the flame doesn't quite go out. It's a pilot control, but it has to be different for every length of pipe to each burner. So now you can turn your light out in the knowledge that it will come back on again afterwards. It's not computers, but it is lighting control. Theatres tended to burn down a lot. So when this newfangled thing called electricity came along, really quickly theatres started adopting it. Interestingly, theatres really quickly adopted gas as well, because some producer probably figured out it was cheaper to pay for the gas than to pay for the people to change all the candles 3 times during the show. You know, economics always tends to win. Electricity, they probably thought, my insurance premiums will be a bit lower. Let's go with the electricity. So just 3 or 4 years after the light bulb was created, the Savoy Theatre in London started being, it claims, the first theatre lit by electricity. Now, I've seen that claim in so many places now that I don't believe it anymore. The light bulb is still related to the sun. It still has fire in its soul. It's still a burning thing, but because it's contained in a vacuum, contained in a glass envelope, it's a bit more controllable. And if you start to add things around it, if you add reflectors and you add lenses, which is basically what we're seeing here, you start to be able to control where the light goes. and not waste it lighting bits of space you don't care about. So just to complete the, not just do lighting control nerdiness, but this is a Strand 23N, Jim, correct? Sawn in half by Strand, because in the olden days, before Photoshop, if you wanted to show how your thing was made, what you did was saw it in half. There's a whole set of these, which are beautiful, beautiful objects. And probably if we filled this room with a bit of smoke, you would actually see exactly how the optics of this light worked in a way that was much better than anyone trying to explain it or draw it. All this lighting stuff with electricity, I think, started off in the hands of technicians who would respond to what a director of a show was telling them to do. Oh, I think I need a blue light over there. Oh, okay. I think I need a red light. But over time, as the tools grow more powerful and people realise just what you could do, a whole bunch of pioneers started appearing who wanted to manipulate the space with light, wanted to take control of the light. So that was people like, in America, Abe Feeder, who's up here, Jeannie Rosenthal, who's up there, in Britain, Richard Pilbrow. They invented this profession that we now call lighting design, which again sounds slightly pretentious, but effectively what you're doing is deciding what to do with the light in the space. So for a show, you'd read the show, you'd figure out what you wanted it to look like. Maybe that's realistic, maybe that's completely surrealistic, maybe it's something else entirely. And then you would figure out how to achieve that. You would draw, probably the way it's ended up working is a lighting plan showing, I need these lights in these positions around the theatre. These lights need these colours in, they need to be pointing in roughly this direction. This is my plan for what I want to do. And then the electricians would figure out how to get those lights, hang those lights up, plug them in, make them work. Once they've done that, the light designer comes back in. This is the section, so the side view showing how high all the lights are, and also where the beams of light go and whether the audience can see the lights or not. Sometimes you might want them to see them, sometimes you might not. Focus the lights, so you say, this light in my mind is designed to point to this point on the stage. So now you, electrician, pointed at me here. So you lay out what your lights are doing. And then you would sit down at now production desk with a set of computers probably, but we're about to see how we got there, and you will turn out the work lights, start with a black space in front of you, and you will literally start creating the light of the world of the show. Simultaneously the most amazing and shit scary thing you can possibly imagine in your life. Oh yeah, so there's that in fact is that light there, and there's some of the other ones. 243, big one, 2K, and that's a 263 trivia. There's lots of variations of this light with different lenses and different shutter sets, and you can tell the true lighting fanatics because they get it right. We'll just go back in time quickly. So if you want to make a light fade up and down, just like you do at home, what you really need in the lowest form of technology is a dimmer of some kind. And the dimmer might be a resistor with a slider on it to change the resistance, to change what you're sending to the light, to make the light fade up and down. This is a Junior 8, which is a Strand product for years that you probably don't find them in schools anymore because it turns out they're full of asbestos. But in my lifetime, you still found these in schools. It's 4 dimmers. There are switches at the bottom, so you can have 2 lights plugged into a dimmer and you can decide to have one or other or both. So it's sort of dimmer doubling kind of thing. But you would literally have to run the show by making changes live during the course of the show. This is the New York version of that. This is called a piano board, which is resistance dimmers with handles. And you're directly manipulating the light. You'll see that you'll be surprised later on to discover that Broadway is still using these into the 1980s. Or you can do the big grown-up version. Yeah. Gasp of recognition from over here. So this is a close-up, and that's another close-up of Grandmaster. So now what you've done is you've said, okay, I've got all these direct dimmers, so behind this are a load of dimmers. There's a load of resistors with wipes on them. But it might be that I've only got 2 hands, and it might be that I want to move more than 2 things at the same time. And I can do that with bits of wood and my arm and my leg and my friend and the broom handle. But there comes a limit. So somebody came up with the bright idea of, you put a shaft through the dimmer wheels. You have a control on the wheel on the dimmer. This is a dimmer control, but you can lock it onto the shaft or not, and then you can turn the big handle in the middle, and you can move a bunch of lights up together, or you can move a bunch of lights down together. What you can't do is move them up and down together on one shaft, but your rig might be split across multiple shafts, so that you could have one set of lights coming up and one set of lights going down. You couldn't set levels, so what you had to do is, as you're winding the handle, and remember that the more things you lock on, the harder it gets to turn the handle, plus all the heat that's not going to the lights is coming out the back of this thing. So the fact these guys are wearing fashionable jumpers makes me think they're not actually really doing a show when this picture was taken. As you get to the right levels, you have to turn the handles to let the things off, so the lights land at roughly the level you were aiming for. There are a lot of these in the world. But the other problem, just to keep in mind, is they would have to be somewhere on the side of the stage. So the people running the lighting couldn't actually see the show that they were controlling the lighting for, other than peering around the corner like this, which is not ideal. A recurring theme that we'll find through this is lighting has become very good at stealing or borrowing, or whatever you might want to call it, technologies from other industries. And in this case, this is a gentleman called Fred Bentham, whose job title was something important at Strand, Rank Strand, Strand Electric, head engineer, head designer, who knows. He was sort of a multitasker, multi-skiller. Bentham had this very particular obsession, which was colour music, which is performing lighting onto objects to music, which basically is what rock and roll lighting now is. I mean, he didn't, this was probably nice classical music, but he's inventing the idea that lighting can be a thing within itself, rather than something that's part of just lighting actors or performance. Doing colour music on this and this and this is not easy or really possible. So Bentham wanted a tool to do it. Strand, it turned out, were based in West London, which is quite close to the Compton Organ Company, who made big church organs. And if you're going to perform music, maybe you want a musical instrument. So there's a suspicion that Bentham did this entirely for his own end and then found a way to sell it to the world as a product. But what he made was this. I'll just skip over that, which is the Strand Light Console, which is basically an organ for lighting. What made this work was that somebody had had the idea that you could take these big mechanical dimmers, and instead of moving them by hand, you could motorize the shaft, and you could motorize, using a clutch, the connecting of the dimmers to the shaft on the So now you could control that remotely. So one of the many advantages of this was it could go somewhere in the auditorium, so you can see what you're trying to create. Quite how it operates, I've operated a sort of mini version of this, because these came in all shapes and sizes. This is a small version from Bristol, is that right, Jim? Bristol Old Vic, which is a much smaller number of dimmers. And somebody has connected this up to a PC with an interface card to talk to modern day dimmers. So you can run cues on this, which is crazily fascinating. I'm going to skip over this, and I'm going to say, I'm not going to skip over it, I'm going to say if you want the details of how you played this instrument, I'm going to refer you to Jim. But what we are going to say is over here, which some people have been looking at going, what the hell is this? This is RAM. This is memory. This is crossbar moving bits of metal that can store information, which was group selections for the light console. And the number we came up with, what's the number, Jim? From one laptop.
One laptop's memory, 17 of the largest container ships in the world would have to carry this stuff to have the same memory as you got on a laptop.
It's not very much memory, but nonetheless, it's memory. And the light console was 1935 onwards. So quite a long time ago, a machine had an ability to remember and recall stuff, which is kind of amazing. This one still exists. This is the Drury Lane light console, which Jim now has, and you'll recognise some of the reprobates from the back of the room posing with this thing. But so the foot pedals control the speeds of the shaft, so you can make fades go quicker or slower, and the keyboards and the stops were for selecting lights and what they were going to do. Were they going to go up in level or down in level? But the problem still is you couldn't decide where they were going to land. You had to wait till the cue looked about right and go, you stop, you stop, you stop, you stop, you stop. effectively. I did find a picture very late. This is one of the motor-driven clutch dimmers. It's not a very good picture, but it gives you an idea. And that's that, just in case that didn't make it here. And that's a close-up of that. This is Bentham at the light console with the Grandmaster behind. So I found this last night, and I think the reason for the success of the light console was people realised they could run the show sitting down. That's my suspicion. As this career or profession of what I like to politely call anally retentive control freak lighting designer came along, the light console didn't work so well because they wanted a state to look exactly the same as they created it when you next did the show tomorrow and when you next did the show the next day. And the light console couldn't really do that. So Strand ultimately gave in to commercial pressure and created this, which is System CD, which you'll recognise as a sort of hybrid of faders for controlling lights and the organ stops and the pedals. So now you could preset levels because you could set a level and the drive would drive the dimmer until it realised it had got to the level and then it would release itself. So now you could make the lighting look the same. This one still exists. It's up in Yorkshire somewhere. The next big revolution in control couldn't come until you changed the dimmers and got rid of all this giant, enormous mechanical stuff, which probably made some really fantastic sounds that I really wish we could also have recorded at some point in history. But electronics came along. This is a Thyrotron dimmer using valves, which meant now you could have a lighting control with, this is 2 presets of faders. So it's 2 sets of faders controlling the same lights. So that means you could set up a cue here, and while that's live on stage, you could set up the next cue here, and then when you were ready, just by moving 2 faders, you could crossfade from one look to the other look. Oh, here you do it with the big windy handle. Every now and again, technology let you help an operator who didn't understand the technology at all, which sort of lighting controls still aspire to do. So this, I'd imagine, is for a cinema or something where there's a permanent rig. And you don't ice rink. You don't want somebody fiddling with all these faders. And there's a rig which is like permanently coloured. So now you can say to the guy who's running the venue that day, just make the lights go green, which is kind of clever. It's a better interface, if you like. This is just Jim's collection, but these are manual multi-preset desks that controlled by now solid-state thyristor dimmers. So this is the control from Glyndebourne. So now what you have is multiple presets and the ability to divide a preset up into groups, which is why there are 3 faders for each of the 4 presets. So you could mix more combinations of lighting together. And that's the individual faders. So that's how you set the levels. That's another shot of the same thing. This is the old Vic. So again, manual control. You're doing the work. This is the control I grew up on in college. This is the Strand SP. This is probably a 6, maybe 60 probably. So it's 3 presets. So now you can get 2 cues ahead. You can have the state on stage, the next one set up, and then the one after that set up. So now, if you're going through a quick show, you can still do the cues because you can be further ahead of yourself. As soon as you get into the next cue, into Q2, you preset Q fader bank 1, and now that's Q4 ready to go. As soon as you get into Q3, you preset, and you're constantly in this race to be ahead of yourself, which is brilliant if you sort of get the hang of it, and slightly scary if you don't. But the problem is, the limiting factor in all of this is, at some point, you have to stop and write everything down. At some point, you have to interrupt your creative process of making lighting to say, okay, in this cue, channel 1's at 50 or 5, channel 2's at 7, channel 3's at 8, and of course that scales badly because the bigger the rig gets, A, the further you have to reach to the faders, B, the more you have to write down and then reset. So there are people who did it really well, you know, and amazing shows happened on exactly this kind of technology, but ultimately you would hit the limit of what you could achieve. At which point I'm just going to pause from our history tale to do some questions, which kind of chart some of this stuff. So question 1 is, if on your cue sheet you don't write anything down, does that mean in that cue the light doesn't change, or in that cue the light goes to 0? Neither answer is wrong. But if you're doing the opposite from your friend, the lighting's not going to look right that night at all. The second one, and this is really important, and yet even in the world of lighting, so few people think about it, that it's not true. We use the word Q very freely, Q6, Q7, this is the look of Q9, whatever. But the important question is, does Q mean the static state, the look you've made, or does it mean the transition from one state to another? And again, neither answer is actually wrong, but in the history when we go to memory control, it has quite a big bearing on the way computers dealt with these kind of problems. The other thing I'll just say about, because it seems obvious that the solution to this writing down thing is some kind of magical computer device that when you press a button can magically remember everything, and when you get done can magically bring it back. But the things to remember about lighting compared to anything else is when you press go to run the cue, you kind of really want it to happen right now, because if you're trying to do it on the beat of a music, it has to happen then, not in what I lovingly call Windows time. Fades, even slow ones, must be smooth, and this might be a problem because your computer might just be storing discrete levels. And if you haven't got enough discrete levels and you're doing a slow fade, at some point you might start to see the light do this, which isn't really very satisfying. Old school lights help you because there's a natural damping of the filament, but nonetheless you might start to see the light step, which isn't bad. Nothing ruins an audience's mood quite like the desk crashing and all the lights going out. Just saying. We could try it now as an experiment if we like, but I can tell you it won't work. So, computers are an obvious thing, but computers are really hard, and particularly if you're a company where your entire history is building big, giant mechanical things, the move to technology that you don't understand and is new to you is really hard. The upshot of which is that ultimately Strand Electric went bust or were subsumed into the Rank organisation because they spent all their money trying to make all of this stuff work. And they weren't the only company that happened to. And because we're in a time way before the internet, it's kind of quite hard to find pictures or information about some of this stuff. But I believe, and people can correct me if I'm wrong, this is KTV, which is a punch card memory system made by Strand in 1959. They built it as the first fully automated lighting control. It used punch cards. When they launched their next control, suddenly, as Strand tended to do, they were backpedaling and go, well, we knew it was actually not very good, because we know punch cards aren't very good for the dynamic way that you make cues, and basically always change your mind all the time. But, I'm sure they would have been happy enough to sell it to you in 1959. The first success story kind of the age was IDM, which is instant dimmer memory. Which is what its name suggests, was you could set a state using the faders, which you're completely familiar with. You've got 3 banks faders like you always have had. It's a completely familiar tool. You know how it works. You haven't had to learn anything new, except that at some point you can say, I'm going to call that 101 on these little rotary switches here, and press record, and the machine will magically remember it for you. And later on, you can get back to that look without having to manually set it up. And in 1965, I have to confess my age and say I wasn't around then, that must have seemed like some kind of miracle from heaven. And even if it was a bit unreliable, and even if it sometimes didn't quite bring the lights back to exactly the levels they were before, because some of the converters were a bit rough around the edges, it probably still felt like a miracle from heaven. This one is a late one, which was in the New London Theatre when it was first opened, which we've rescued recently, and we think the Sperry memory drum, which it used for data storage, is still in the theatre, because we think they effectively built the theatre around it, and now you can't get it out. So it's still there. I'm not going to say the facts and figures, because they're all there, but it must have been pretty amazing. And Strand made it well enough, despite the problems, that they sold 20 of them. What I've tried to do is interject some of these little things, and if people are here in the room who said these things, don't be shocked, outraged or horrified if you see your words up on the screen. If you want to take credit for them, just go, yeah, it was me, I said that. But it's interesting that in Britain everyone turned the things off every night like good energy-saving eco-green people, and as a result they broke down all the time. Whereas in Europe they just went, no, we will just leave them on, and they were much more reliable. IDM was later redesigned into a system called MSR, which probably stands for something like Memory System Rank, and it was the first job of a young engineer who's sitting here, called Dave Burtonshaw.
1971, by the way.
Oh, see, that's why you're all here. There's three interesting things I've discovered while compiling all of this and some other stuff I've been doing about all this history. One is there are a lot of lighting controls that have been made in the world, memory lighting controls, lots and hundreds of them. I mean, a ridiculous number considering there aren't that many shows in the world. But of the teams of people who've repeatedly made successful lighting consoles, that's a much smaller number. That's maybe 3 or 4 or at most 5 groups of people in the world. And the team at Strand at the time, which is led by Martin Moore, who's sitting over here, being all coy, and David, we will see sort of achieve miracles. So MSR was a redesign of IDM, and the big change is that the little rocker switches have gone, and there's a numeric keypad here, which if you go to that whole hog 4 there, which is a brand new launched this year, last year lighting console, you will find exactly the same keyboard in the middle of that desk. That is just the way we work now. That's the rack full of electronics. That I thought was magnetic tape, but I was corrected, and it's in fact paper tape. That's how you do key storage. That's some attractive 70s fashion, because it's social history as well as just lighting history. And we even know the name of the model, because that's how good we are at this whole history thing. Unfortunately, for Strand, there was a competitor. And the thing we still see to this day, which is an industry gets stuck in a rut until a disruptor comes along, which is the iPhone model, or the Macintosh model, if you like, as well. Thorn did that. Thorn decided that they wanted some of this lighting market. And the reason they wanted it wasn't because of all these namby-pamby theatre people. It was because of this new market which had appeared, which was lighting control for television, and in particular colour television. Colour television, you suddenly needed more light, and it needed to be, with the early cameras, much more precisely controlled. So there was a sudden need for memory control, because you needed to get it spot on, otherwise you'd have to redo all the settings on your cameras. Thorn also, I think, just wanted to get into a pissing war with Strand, because I think the people who ran the two companies didn't like each other very much, is my sense.
That's right.
Martin says that's right. Q-File was a revolution because it was memory that worked reliably, from what I understand, first of all. But second of all, it solved a problem. Because the problem with IDM was, if you set all the levels on all these faders and then you record the cue, what happens to all the faders? Because as soon as you run the next cue, they're all wrong. So if you move the fader now, does nothing happen because it knows it's wrong? Or does it suddenly jump to the level? Or what happens? And if you want to edit the cue, do you have to manually set all the faders back to the right level before you can adjust them? Or is there some secret push the button, twist the thing that you can do to tell the machine, I'm just adjusting this light, don't worry that the rest of it's wrong? It's a problem. Plus it's a problem because as the rig gets bigger, eventually A, the faders are going to fill this room, and B, they're going to be really expensive. So the Thorn revolution was to say, instead of you going to the control, we're going to bring the control to you. How are we going to do that? Well, we're going to give you a way of selecting channels. Interestingly, we saw machines with keyboards exactly like this in the calculator section out there. It's really interesting doing this talk here because of that. Because this is the layout of the time from calculators and adding machines. But also from this, you can see that probably on this machine you could only control up to 299 channels, dimmers, whatever we want to call them. One solution to to where the faders are thing could have been if they're all motorized, because then when you went to the queue, they could have all moved to the right level. But that would have been phenomenally expensive and unreliable. The Thorn
But the Germans did it.
Yeah, interestingly, I meant to say at the beginning, I'm sort of glossing over Europe. Good or for bad. We can do that another day. The Q-File innovation, Tony Isaac's innovation, was to say, bring the control to you and give you one motor fader. So this is motorized. So that as you select a channel, the fader jumps to the right level, and then you can adjust it. And then you do the next channel, and then you adjust it, and then you store the memory. But every time you select a channel, it moves. So now also it's giving you an indication of the level the light's at before you adjust it. It's kind of brilliant. There's a whole set of other problems it throws up, such as what happens if you select 10 lights and they're at 10 different levels? How do you get them all to full? But it was a solution for television, where really they weren't doing groups of lights mainly, I suspect it worked. Inside it was apparently like some kind of miracle it worked at all, because it was all originally individual transistors wired together to create logic gates. I mean, it sounds scary as hell. Later on it got rationalised a bit, from what I understand. But it basically stole the market away from Strand, particularly in television and later in theatre. It's not a computer. People keep pointing out to me it's a lighting machine. It couldn't do anything else. Hand-woven core storage, but it worked. This is in a theatre. This is the Leeds Grand. Here what they have is, as well as the fader, they want to see the levels of lots of light. So those are individual light bulbs wired back to the dimmer room. So as you fade a light up, for real, the little mimic light bulb comes on as well. And the clock is a reminder that you still couldn't run cues automatically. You were still doing fades by hand. So if you wanted to do a 10-second fade, the clock was there to help you count your Mississippis as you did the fade. Strand's reply, I think it would be fair to say, was DDM, direct digital memory, he says, looking around the room, something, digital memory, digital dimmer memory, there you go. Bentham's solution was different because he wasn't convinced that the theatre world was prepared to have one controller instead of lots of controllers. But he also knew the problem of these faders that got stuck. So the solution he came up with, or Strand came up with, was, I think, nicknamed the fried egg. It's a rocker switch, which is what this is a bank of here. Because now the control has no level. You can select a light and you can go up or down. It's a solution, but the problem is you now don't have anything at the control telling you what level the light's at. So probably there's another indicator somewhere else on the console to tell you that. Here, Strand made the move to using a computer that wasn't made by them to do the work. So it's back to the adopting technology from others from Compton. And here it was a digital equipment PDP-11, some of which we've seen around the museum today as well. The other thing I found fascinating, as well as the 5 groups of people, is that independently, as far as I can tell, almost everybody from every company who did this, apart from one, used digital products. Whether because they were accessible or more cost effective, or they gave you better support or better documentation.
They were mostly, principally, I think they were best designed for process control for industry.
Okay.
And as a result, they could interface to external peripherals much more easily than the average computer.
So interfacing, but almost everybody used one or other type of digital product. It's a really interesting coincidence, or everyone arriving at the same conclusion for the same reasons. This is one of my favourite quotes. There's been a correspondence going on about these consoles between a whole bunch of amazing people and me for the last year. And this is the things like this that you discover are kind of amazing. Those guys were good. And then somebody else going, nah, it's just what we did. There's nothing special about it. And then these guys, you had to make them all work. So discovering that the reason your console isn't working is because there's a TV transmitter tower up the road and it's messing up your memory. You know, the smarts to go and figure that out is also pretty amazing. You know, this sounds slightly ridiculous, but I have this sense through all of this of this new wave of technology being born around us. Whereas now it feels a little bit like you go, okay, here's a new version of the thing I've used before. I kind of wish I'd been born, I don't know, 40 years earlier, because it might have been fun to be part of that. Not that it's not fun to be part of the iPhone generation. In America, because my split has sort of been, because the way I work is I do shows here and shows in America, and we tend to work more like the way Broadway particularly works than in some ways the way Europe works, in terms of lighting style and all kinds of other things. So in America, there was a console around the same time called Sweet 16, which used another DEC product, LS11, which is a processor rather than a rack-mounted computer. The name to watch here is this one, Dave Cunningham, because he will reappear in our tale. So we come to MMS, which is, you can see, you don't need to look at the pictures because the real thing is sitting here. This was Strand's response to Q-File. So MMS stands for Modular Memory System. So if you wanted the console, a Strand salesman would show up with a set of flat cards, life-size representations of those modules, and you'd say, well, I need one of those, and one of those, and one of those. And in my control room, I need to arrange it like this. And once you'd figured out what you wanted, the order went back to HQ, and the machine whirred into life, and an MMS was created for you. You couldn't, I don't think, then swap the modules around. I think once it was made, that was it. But the innovation here is the thing you're looking at right there, which is sounds really obvious to lighting people now, but the fader wheel. Because the fader wheel solves all the problems. Because it doesn't have a beginning or a middle or an end. It has no level. When you select the light, whatever level it's at, you can just adjust it up or down. And if you select a lot of lights and they're all at different levels, you can just keep wheeling them up, and they'll all hit full one after another, but you can just keep going until they all hit full or until they all hit zero. It was sort of a knockoff, I think is a fair comment, in that a Swiss company had made a similar controller using a flat belt. But Strand, who'd grown up with this quadrant fader, which is one of my favourite interfaces devices ever, because it's so natural feeling just to put your hand on it and move the fader. It's much more comfortable than the flat faders we all now deal with. This one also has a switch here and was illuminated, which is kind of cool. But the Strand Collective saw the belt, recognised the idea, but thought that doesn't feel very natural. It would be more natural if it followed the curve of the hand, just like the quadrant fader did. And if you take a wheel and you mount it on a shaft, then that's pretty much exactly what you end up with. So you can see one on the channel control here, you can see one on this, you can see one on this, which is a much later generation of control. And then the other switch, because it's new tech, the new tech, coming tech of computers and touchstone phones and all those things, rather than the old tech of adding machines, is the columns have been replaced by this. It's moved from memory to channel selection. And so now you can pick your channel and adjust them in any way you like. What you then need is something to tell you what level it's at, so there's a meter above it. But the MMS sets the way we still work to a greater or lesser extent. That's the colour version. But as I say, the real one's over there. Those were some of the other modules. So you could get a mimic. If you weren't ready for this newfangled world of typing in channels, you could get a button array so that you could select the channels with one push, which lots of lighting people who came later on with big rock and roll desks insisted they had to have, and have arrays of buttons that look very like that. That, I think, is a prototype, which doesn't quite look the same. That's the specs. So this one wasn't based on a computer because Strand were trying to build it down to a price where it was more affordable. So it was a Dave Burtonshaw team machine, handcrafted out of TTL logic, power hungry, and apparently a slight nightmare to make work, to the extent where ultimately, to model the power consumption of all the different modules and all the different combinations, they wrote a computer program. So that's computer-aided design of a sort. The key feature of it was the bus, which linked it all together, let all the modules talk to each other. And it could control 480 channels, which is a lot of channels in its day. Power supplies, problem, ultimately it did have a processor added to it, so the tape drive, which we've got one of, which is hiding behind Martin, did have a 6800 processor in it. Ultimately, it had a video display. So here we see something else arriving. Now you can see the level of lots of lights at the same time on a screen. That's over here. That's the fault log from this exact MMS, which is from the theatre in Chichester, which is amusing. The social history part. So they sold one to North Korea. As you may know, is a place you're not meant to go. But Strand's team of engineers went and installed this thing in Pyongyang in North Korea. I'm just going to steal their story, but the story was, before they went, our government said, obviously you're not meant to be there and we can't help you, but if you can have a look around while you're there, and when you come back, report back. And my other favourite one, so this is the control room in Pyongyang. My other favourite one is this, which is how they got paid for the job. Used pound notes out of Berlin, which is completely fantastic. So this is like 1973, 74, 75, 76. Meanwhile, on Broadway, they're still running shows on this. And they're still running shows on this for all kinds of weird political, financial, producery reasons. They couldn't really do anything else because all the Broadway theatres still were running on DC power. So they couldn't use thyristor dimmers because a thyristor is a switched waveform. They were still doing that because the theatre owners in New York don't put any equipment at all in the theatre because they say, well, we've got the building, but whatever you want for your show, you have to bring in. And the producers were saying, well, I'm not going to pay for AC power because you'll keep it and use it for other shows, and that's not fair. So this fight was happening. Plus, at the same time, New York still has this formidably scary union of stagehands who earn a lot of money and want to protect that, but they want as many of their friends as possible to be employed on the job so that the collective social power of unionism, which we've lost in this country, keeps them all in work. So they like the piano boards because it took a lot of people to make them work. And then this lady came along. He's called Theron Musser, who was one of the pioneers of lighting in America. And she had worked a number of times with a director called Michael Bennett, and they made a show called Chorus Line. And they made it away from New York, out of town, well, uptown, downtown, the fringe of New York. And they made it on a multi-preset board, and it was a monster smash hit. And it was going to transfer onto Broadway. And the producers said to her, right, we're a monster smash hit, what do you want? And she said, I want to be able to do a cue like that on the music with every beat if I want to. And I can't with this, and I can't with those piano board things. I need memory control. And the producers went, shit. Maybe we shouldn't have promised her whatever she wanted. Because the show is, if you get a chance to see it ever, amazing to look at, because she created this completely abstract lighting based around Mondrian paintings. It was blocks of colours of light that people would move through. And it's one of the most beautiful bits of lighting you'll ever see. But they had to find a computer control in a hurry. Now, they could have called England, is the interesting thing, at this point in time, and said, hey, we hear you've got these fancy memory boards, please send us one. But Americans don't really like doing that. Instead of which they found a university professor called Gordon Perlman, who was sort of dabbling in making memory lighting controls in his spare time. Again, using a DEC mini computer, so a PDP-8, hence the name LS8. And they flew him to New York, and they flew him to the machine to New York, and there was a lot of resistance from the unions, and there was money changing hands in envelopes, I suspect. But the console was installed and ran the show for most of its run. My favourite thing about this is that when they first got the console, it couldn't auto-boot. You had to toggle the switches to make the thing boot up and wake it up. But it knew the show because the core memory retained it. Later on, they upgraded it with a floppy drive, so they had a way of archiving the show. But now, because that took some memory, there wasn't enough memory to hold the entire show, which is a bit of a catch-22. So, normally what happens then is in the interval of the show, when the audience are out getting drunk, you load the other half of the show in. But a chorus line doesn't have an interval. So what happened is, there's a monologue scene in Act 2 where a guy stands on stage in a follow spot talking about how dreadful his life is. And during that monologue, he's in a follow spot, so that was the opportunity to load the rest of the show. Nerve-wracking, I'd imagine. But also, as the show is loading, the sample and hold converters feeding the dimmers are losing signal. The lights that were on are fading out. If you go watch that show, that cue is still part of the show. You now have to make it very deliberately. So that was part of the show. That console ended up at a computer museum, the American Computer Museum in Boston. So there is precedent for showbiz. See, I'm doing a bit of a sell.
Sadly, that museum doesn't exist.
Yeah, I know. And nobody quite knows where it is now.
It's in.
But it's the console in California.
Yeah.
I know where the museum is.
A lot of the kit from Boston was lost.
Yeah. The US tour didn't run on this console because there was a patent fight between another console manufacturer who claimed a patent on consoles with displays, and the producers were too scared to use it, so they found an alternative. This is the screen for the LS8. The LS8 had a channel screen. The alarming thing is, in many ways, consoles today have channel displays that look exactly like this, except maybe in colour, but very little has actually changed in some ways. Gordon Perlman is one of those people in that group who's developed a lot of other consoles since. So this is the various Kliegel Performer consoles, these two, which ran a lot of shows in America and in London through the 80s. So Cats, for most of its life in London, ran on a Kliegel Performer. Skirpan, this is the one that put LS8 out, and its unique feature was it used a light pen on the display as the way of selecting channels. So it was made for television, really. But again, it's a PDP-8. This is over there. This picture I love, though, because it shows how you put colour information on a black and white screen. And I was fascinated to discover that the Space Invaders machine in there does exactly the same thing. Berkey, they were the ones who made a mistake and used Singer computers, who really make sewing machines. So therefore, when Singer got out of the computer business, Berkey really weren't in the lighting business anymore. That's the problem with relying on others. This is the National Theatre in England, which is a remarkable project at a remarkable time. So there was 100 years of discussion about whether there should be a national theatre, and ultimately it was 20 years probably of figuring out what that national should be, 10 years of figuring out the detail until it ultimately finally opened in 1976 in this Dennis Lasden brutalist concrete building which you love or hate. I mean, there is kind of no middle ground on the building. It's a bit better now that they've given it a bit of a clean. And this is lightboard. And lightboard is mainly the reason I got into all this history stuff. And lightboard is the work of these people over here, and it's amazing. Because the opportunity was that the National Theatre was going to operate at a scale that really hadn't been seen in British theatre before. There were 3 theatres in the complex, 3 auditoria. They were going to perform in rep, so you were maybe going to do a different show every day. But also maybe you were going to do several changeovers a day. Maybe, they've never managed to do this, but the theory was you could rehearse one show in the morning, change, do a matinee of a different show in the afternoon, change, do a matinee of a different show in the evening. For reasons of economics, they don't actually do that. But the building was designed to allow that. And for lighting, that meant what you couldn't do is go around having to refocus all the lights for each different show. So light designer Richard Pilbrow, who was also the theatre consultant for the building, designed a lighting rig where there were enough lights that you could keep lights permanently focused for what you wanted to do most of the time. And then you would have a few specials that you refocus between shows. And then, this is the amazing thing for 1975, you'd have some motorised lights that could move around and reposition themselves during the show or between shows. And there was no controller that could handle most of that, and in particular the fact that because you had lots of lights permanently rigged to be used, whereas most theatres at that time maybe had at most 120 dimmers, the Olivier, the big theatre, had 768 dimmers. And that's a magnitude, order of magnitude difference in terms of what you need to control. Plus, Richard didn't want just to control like he'd always had before. As a lighting designer, he felt limited by you're in Q1 and you crossfade to Q2 in one time. He wanted to be able to manipulate light and have things change in times like you see light change in real life. He also was bored with this interaction where you told somebody to do something and they did it, because sometimes it's easier just to grab the light and mess around with it, but then you don't want to have to worry about recording it. Somebody else can do that. So he designed a system with these wheels over here, which were a pallet that could go in front of the lighting designer so that they could manipulate the light directly. It went out to tender, Strand accepted the tender, Strand delivered the product. The building opened in 1976. The lightboards ran the shows in the 2 main theatres for the next 10 years. This is the main console which lived in the control room. So submasters for, again, mixing light. Most desks now have one controller. You can only control one light or group of lights at a time. It's very hard to mix light. 2 displays to give you information about what's going on. Playbacks with rate override. So even if you program a complex time sequence, if you need to make it a bit faster, you can. And then this module, which lifted out and went and sat down in the auditorium in front of the lighting designer so they could play with it if they wanted, which is called a palette. Before it got its marketing name, it was called TCS, Total Control System, because that was the ambition. So 800, maybe the spec was 1,000 dimmers worth of control, moving light control, colour change control, slide change control, things that had always been separate systems before, if they existed at all. Heads-up operation, run the desk without looking at it. It could do things that consoles today can't do, which is amazing to me, ridiculous to me. 11 of them built around the world. This is the Olivier, it must have been early on. That's David Hersey. That's David Hersey's son, who's now 30. That's Alan Jacoby, who was an electrician at the National, who now runs the rigging company Unusual Rigging, who do all the big, scary events and rigging things. But tucked down there is the palette. It wasn't perfect, but the user was happy to provide feedback, or in some cases Strand was surprised to discover that nobody was using these fancy facilities that they'd spent all this time engineering. That's a later lightboard, because it now has 6 wheels instead of 4, with Richard Pilbrow driving it, which must be in Germany somewhere, and a later lightboard because it has colour displays. And those are the facts. Now, if you're interested, the bits of it we found so far are over there, and the specification is over there. And the specification is an amazing document because it must have been written in the late 60s or early 70s. And it says things like the data highway will pass around the theatre, which is like the information superhighway, but not quite as fast. It says things like a function to change which channels you're looking at is called roll, which is just like scroll, but choosing a slightly different word to do it. Again, it's like seeing the future written down in front of you. It was based on a mini computer again, PDP 1135, but it wasn't fast enough. It couldn't do the processing fast enough to update that many channels at the speed they needed to happen so that you didn't see steps in the fade. So Team Strand developed their own, effectively a coprocessor that handled that part of it. It would take the numbers out of the PDP 11 and then figure out how to do the crossfade. It's updating each crawler in less than 30 milliseconds. And as I understand it, it was right at the absolute limit of what you could do. It very nearly couldn't be done, which is, again, for the frivolous task of turning lights on and off, it's kind of amazing. This is David's explanation. Now, I've looked at the clock and it's an hour and I've still got like 9 hours worth more stuff to say. So you're going to feel like you're fast forwarding through these slides, and we'll do another talk another day where we see them more slowly. But just to go to the other highlights, so that then you can all ask questions about it. And if you want to see these slides, in fact, maybe we'll just print all these slides and put them on the internet somewhere. This is the why you shouldn't just plug a very fragile computer into a main circuit that's also feeding dimmers that chop up the electrical waveform. Mainly what happens is your computer will stop working. Later systems, colour, more wheels, etc. This is a nice German man, I believe, running very proud of his enormous lightboard. This is at the Littleton, at the National. The really interesting thing is ultimately it was replaced because they couldn't get spare parts, but the controller they replaced it with, which was its successor, the Strand Galaxy, couldn't do some of the things Lightboard could do. It couldn't control moving lights. So the National had to engineer their own control system using a PC and writing custom software. That's what it looks like now, which is a bit sad. And the modules you see in that picture are the modules here. But we sort of think we know where the rest of it is, and we sort of think we know where the processor is, and we sort of think we can get it all back together, and then maybe we'll just plug it all in and, see what happens. This looks like the level control from the MMS, but this is the moving light control, which is why it has things that say things like pan and tilt on it, which is interesting. That's Richard Pilbrow reunited with his lightboard last summer. This is the supposed follow-up that looks amazing, but never actually made it to market. It's also sort of common in lighting control. Galaxy, its successor, originally called DDM3. So the factoid is the nameplates on the early consoles said DDM3 on one side, Galaxy on the other, because nobody had quite decided in time what they were going to call it. But you can see the family resemblance, except now it's based on microprocessors. It's based on the Motorola 6809, but lots of them. Because if you wanted the maximum 700 and something channels, you needed 16 of those processors to do it. The other interesting coincidence for the computer fans amongst you is almost everybody who's done this has used Motorola 6800 processors. And again, I'm sure there's a perfectly good reason for it, but it's interesting that the ones who didn't make very successful consoles. So that's a hybrid at the end of the Galaxy Nova, which is the last one of the line in grey, and some of the other modules on the side, which I think is from Kleinborn. Mini versions of it, so Duet. My first memory controller I ever used, the M24. 6800 again. But now, instead of tens or hundreds of thousands of pounds, you can buy this for £5,000, which to a young me felt ridiculous and got me in all kinds of trouble when I was a youth. But hopefully we've all forgiven each other now. Even cheaper consoles, so the Sirius, which took over from the scary faders in schools. So 24 faders plus memory for a very good price. Again, based on the 6800 processors. This is probably, we'll look at this and then we'll skip on. Because is blank off or is blank zero question manifested itself because in Britain you always recorded zeros. The boards always recorded the complete state of the queue. In America, because designers had got used to these boards where what you were actually doing was changing from one thing to another, this is a really hard thing to describe, but it wasn't just syntax or logic or whatever, it was how lighting designers had come to think, I'm convinced. They thought in changes. And you still see this because British lighting designers will craft one look for hours. Whereas American lighting designers will make it and then go back a queue and run the queue because they're more interested in the transition than in necessarily the final state. Light palette was the console created by Dave Cunningham, the name we saw earlier, in response to that. It was what we now call a tracking board, so the queues only recorded the changes from one queue to another. Now, if you're a computer engineer, that's a fantastic bonus because each queue suddenly takes less memory and a variable amount of memory, but you don't have to leave this big gap for every possible channel. The other thing he did is Cunningham sat behind production desks listening to the language lighting designers were using to talk to their operators, and he embedded that language into his console. So if the lighting designer was saying 1 at 50, that was what you typed to make that happen. If the lighting designer was saying, okay, make Q1 times 6, the command became Q1 times 6 in a command line. Now, the other reason in Broadway is the lighting designers are in one union and the electricians running the board are in another. The lighting designers aren't allowed to touch the board. So they want to be able to tell the guy running the board what to do without a sort of translation process having to happen in his head. And the more you take out that translation, quite often the faster the communication process became. You didn't have to rely on having a good operator. As long as he could press the right buttons when he was told, you'd get the job done. Digital again, LS11 this time, in the housing, so the thing was self-contained. Command line, tracking, multi-part queues, lots of things which we all now have as standard. Cunningham is interesting because he's the richest person in showbiz, I think, probably, because he designed all these products for all these companies, and then when he left, he went freelance, he designed the Source 4, which is the industry standard spotlight you'll see everywhere in every theatre. He designed the light bulb, which goes in that. He licensed it to a company, ETC, who sell it, and he collects a royalty every time you buy a Source 4 or the light bulb. And if I tell you there are more than 3 million Source 4s in circulation, generations of it, until eventually a new company appeared with a point to prove called ETC, who made a better light palette, because the light palette Strand lost interest in and it got less and less good and reliable. ETC, which was this young company with a point to prove, built a knockoff of it, effectively. They'd tell you the same thing, I hope, which they called Obsession. And now we get into the era where things we recognise as bits of PCs start to appear in lighting consoles. So this was based around a 486 processor with a co-processor. And it had a hard drive, and it had all the things that we now recognise as just being a computer. Yet, funnily enough, this still looks exactly like the LS8 from 20 years earlier. And then it turned into this weird, scary back desk with lots of polished metal. There was some kind of, 90s thing going on. But ETC is, again, a disruptor. So it was Fred Foster and his brother. Fred was a theatre guy, his brother was a computer guy. And they wanted to prove that you could build a Q file for a fraction of the price of a Q file using these newfangled microprocessor things, which they did with a product called MegaQ, which could do almost everything a Q file could do, but it was one box and it cost roughly nothing. 8080 in this case. They were then interesting because rather than selling products, they made products which other people sold for them. And that went on for years. They sold products to Disney until finally they launched themselves into the world with their own line of products. Because they make good products, because they have good customer service, and because they're privately owned by a person who cares about theatre and they look after their customers, ETC is sort of one of the 2 or 3 companies who now completely rule this market, particularly in theatre. And their current products are all PC-based. Their lucky timing was to arrive when this protocol called DMX appeared. This is David's description. It's a serial communication protocol, but until it was made, every single company used different protocols to talk between their desk and their dimmers. If you bought one company's dimmers, you probably bought their desk as well. Eventually, one rental company in New York said, this is ridiculous, I'm bored of this, I'm not buying any more stuff until you guys get your act together and make a common language. And they did very quickly, and it's this thing called DMX, which is a serial protocol which can transmit information for 512 channels worth of stuff to 256 levels, and then it just repeats it over and 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 over again. Everything we now do with it, it's ridiculously underpowered and primitive and wrong, and yet because it's the common standard, everybody uses it. I'm just going to go through my slideshow. This is the crazy one. So this console has a heads-up display, like a mirror with a projection onto it, so you could see the stage through the lighting, which I thought would be really cool. I think maybe they sold one. Rock and roll weirdly hung on to these hundreds of faders because they wanted to be able to busk live music shows. They didn't pre-create shows in the way we did. It looks like a sound desk. Sound is now changing because sound is now downsizing because they're going digital. So big AVO desks, more big AVO desks. Weirdly, again, completely different company, completely different market, Motorola 6800 again. What changed the world was this, which is when moving lights became a product. The National had big theatrical lights, the big versions of this bolted into big yokes, which could ponderously move to a position. Verilight is the light you now see everywhere in rock and roll, where it can move and be bright and change colour and be dynamic. But that's a whole different control paradigm, because now you're not just controlling bright and dark, you're controlling movement and colour and position and shape and texture. Again, the disruptor, the companies who made this were a sound company really, who dabbled in lighting on the side. But they made this product, they showed it to one of their clients, who were a little band called Genesis, who went, holy fuck, we'll have that, thank you very much. And this was their top-end control system for a long time, which is called Artisan. So the button array from N&S, you can see right there again. But this is a crazy console because this console doesn't know anything at all about the show. It's a keyboard to the lights, and each individual light has a processor and memory and a serial communication protocol. So when you record a cue, the light goes, what am I doing now? Okay, that's my Q10. When you press go on Q10, the lights go, have I got a Q10? Okay, what do? Okay, I do this. If it hasn't got a Q10, it just keeps doing whatever it's doing. But that is interesting because now as the system scales, as you add more lights, the processing power and the memory scales at exactly the right rate, which is clever. This is the Oscars in about 99. Artisan always got used on the biggest shows, and these are its successors, which are all based on Apple Macintoshes providing the processing. But the other name you'll see a lot, Anne Valentino, who was product manager for Light Palette latterly, and then for Obsession, and then for this, and now does EOS, which is ETC's current control line. She has a lot of experience in doing this. Other markets, so nightclubs needed controls that did something completely different. This was one of the first controllers to have touchscreens on top of CRTs. It's called Oscar. This is the Compulite Animator from Israel. The rumour has always been that it was an Israeli missile targeting system adapted to the cause of lighting. Wouldn't like to comment. But what it shows you again is, as the problem becomes bigger, you end up with more and more and more controls and buttons and things, and you're back to this thing of everything getting bigger again. So the one I think we'll end on is these guys, the other name who repeats, which is a guy called Nick Archdale, who started off making lighting controls in school based around the BBC Micro, who buried a BBC Micro inside this and called it a product, which he sold to. But who, again, his background was completely different from anything else, because it wasn't theatre or concerts or music, it was raves. And raves are an entirely different thing, because what you want to do now is walk into a venue and make the lights do something. It doesn't matter what they do, they have to do something, and then they have to keep doing it. So the process of creating movement by going a cue and then a cue and then a cue is ridiculous. What you want is a button that just says, just do stuff, which is what this did. Look at those guys. And what on an even bigger scale this did, which was the whole hog, which was the most ridiculously overspecified product ever in the history of the world. And I think they maybe sold 4. But again, it was a PC with a control surface. then that began, the name Flying Pig became, from just being ridiculously over the top, that began this, which ultimately begat the Hog 4, which you see there. This is the whole Hog 2, which was the standard controller for moving lights or mixed rigs from about 1994 for about 10 years. And its innovation was the touch screens and the realization that instead of having an infinite number of buttons, have a touch screen that could change the buttons it was presenting at any given moment in time. It was small, you could pick it up and put it under your arm and carry it. It was basically hand designed. But you see here, instead of lots of numbers and cryptic things, I've always described it as being a bit like working a cash till at McDonald's. You know, like quarter pounder and fries and a milkshake. It's like, I want this light in this colour pointing to this position in this shape. And it became very intuitive what you were doing. And that was its revolution, which everything subsequently has copied. This one was different because it was an i960 and it was all embedded. It was a miracle that this could deal with moving lights. And ultimately the reason it stopped being used is because as rigs got bigger, it just ran out of steam. It couldn't cope anymore. But for its time, it was kind of amazing. There are lots of other things. And what I'm going to do is I'm going to say questions, and while you're asking questions, I'm just going to keep pressing go. So, because otherwise we're going to be here forever. But, questions?
Well, I think thank you, at least at this point, anyhow.
Yeah, well, maybe we should do part 2. Come back.
Fascinating. Thank you. Yeah, questions? Sir?
Yes.
Something that always interests me. When have you got rid of the key for a lighting console?
Yeah, that's a mystery, isn't it? They all used to have these. All of those have those, all of these have those. Yeah, they don't have keys anymore. It's because keys are expensive and you lose them. And I'd imagine. Or you break them off and then you can't do anything with them. But yeah, keys are kind of cool because it always makes you feel like you're about to launch a nuclear missile or something really serious. I mean, the other one that's gone away is better is a lot of the Strand controllers used to have 2 buttons for save and load, but they were called M to D, which was memory to disk, and D to M, which was disk to memory. But it was a bit like, am I pressing the right one? Or have I just wiped over my shoulder?
There are computer equivalents like restore or backup.
Which one do I mean?
You have to get somebody to come and look at me when I press this button, just to make sure I'm pressing the right button. Sorry.
I'll ask myself a question, but this is not computer control, but this was a real innovation. There's a guy called Rob Bell, just to say, if I want to start lighting a show, do I need the real lights, or can I simulate the lights in a computer that listens to the lighting control? And that sounds crazy, except if you're about to light the Olympics and you've only got 2 days in the stadium, you want to get ahead of the game. WYSIWYG is a tool which visualises lighting. It's running over there if you want to have a look later, I think, or a version of it, one of its rivals, actually, I suspect. But WYSIWYG now lets you make surprisingly realistic predictions about what your lighting is going to look like. Anyway, more questions, please. Oh, you're all too shy. Yeah.
When I used to do outdoor dramatics, I was using these Grandmaster things that we've seen, lots of arms and legs. And the theatre club at the time was always pressing me to get electronic dimmers into this.
Yeah.
Because you could get domestic dimmers from an 80-watt light bulb at home.
Yeah.
And I wasn't very reluctant. I know these things, when they go with the bang.
Yeah.
And how often do they take the electronics with them when they go?
Not very often. I mean, in real terms, not very often.
About when did electronic dimmers come in that were reliable?
It's mainly when you went to thyristor dimming, so solid state dimming that wasn't relying on valves or anything else. Yeah. When they added fuses, there you go. That was the protection.
So I take it a given theatre just invested in a whole bank of dimmers with a standard protocol, and then the desk changes more often.
Sort of.
Right.
I mean, it's interesting what's going on at the moment because there's a bunch of theatres in the West End that have Strand dimmers that they installed in the 60s and 70s, which have run fine for 25 years. And there's one theatre in particular in London where, maybe it's actually 15 years ago now, they replaced all those dimmers with a newer version from another company. But now, very recently, they've replaced them again. And you kind of are like, how come the old dimmers could last that long and the new dimmers have lasted half that amount of time? Maybe, is it economics? Is it because you made them cheaper? Is it? But that just feels wrong. Processing, is it because the dimmers now have electronics and intelligence in them which fails? Who knows? But it feels wrong. Yeah.
Like
Yeah.
So there was one example of theatre I used to work in where they did that change very quickly in a couple of years, mainly because of the running cost of the dimmers, and it was more efficient to buy newer ones because the whole running cost was lower.
Yeah.
Or to keep the old ones that had already changed for a couple of years.
I mean, the change that's heading towards us very rapidly right now is that these lights here are not lights as you know them. These are LED lights, which is why you don't feel so much heat coming from them, why they've got a slightly weird colour temperature. But the thing is, they basically have a little controller box, which is on the floor down there, which is or it can be built into the light, which is its dimmer. It doesn't need a dimmer anymore. What it needs is just power to run its electronics. And so what's happening now is the dimmer manufacturers are starting to make dimmers which you can toggle a switch, and they can either be a dimmer like you've always known it for your old lights, or you can turn them into being basically through power. They're a switch, so that you're not trying to dim your electronics devices, which tends to blow them up because you're chopping the waveform to. That's a bad thing to do. But the change that's coming is theatre very rapidly is starting to adopt LED lighting for all kinds of things. And we feel that we will be made to do that more as the government successfully outlaw more and more light bulbs and things that we've always used.
These big moving lights in a very light used to discharge light bulbs and turn them on at 7 o'clock and they stayed on until you went home at 11 o'clock. Right? And they've got mechanical dimmers in front of them, which were still controlled by the same thing. So all these lights you see, the colour changes are mechanical discs of glass, just like they were in front of those things.
And rock and roll did
inside the lights.
The moving light market did that because you could get a very bright, very small source that was rugged. Because the thing is, with a big filament, if you shake the light around, the light bulb's going to blow. The discharge bulb has no filament, so it's more rugged. And also, it's efficient in that if you're doing a rock and roll show where the light's on all the time, it's a very bright light per wattage. The problem with theatre is we mechanically dim it down or even off a lot of the time, but the light bulb's still using electricity. So we're sort of starting to get into trouble because we're not being green.
The first very light was 150 watt discharge, and that was 500 watts, that one. So they were replacing 1K incandescent with much lower wattage now, which because they were much more efficient.
Yes.
And you could build smaller optics because the incandescents had much more lights.
Oh, there's a point of light is always
I think it was like a garden stapler annoying nicely over there.
What gets installed in the average sort of small town theatre now as a new build?
Some dimmers of some kind, like thyristor, all the thyristor
Not
dimmers.
memory control or anything, just simply a bank.
No, it will be a bank of dimmers and a memory control. No, I don't think. I mean, you can still buy multi-preset small boards, but I think almost any theatre would now afford some kind of memory control because you can get very small memory controllers for dealing with very small numbers of dimmers. Or again, what's coming is, because we've all realised that these things are all just PCs inside, well, why not just use the PC? Now, in the big professional world, you're always a bit scared of that because you don't want some virusy something that's got into the computer to do it, so you want to lock it down. And if you're working in a professional world, you want a control surface that's designed to do what you want to do. But if you're not in a super hurry, you can do everything you can do on that desk with a mouse and a laptop, and it will work just fine. And what the manufacturers are now starting to do is to make what they're all calling wings, which it looks like the control surface of the desk, but it's just the buttons and knobs and a USB cable. Yeah. So that if you need that interface, you plug that into your laptop, do the show. But then even when you're finished, you take it away and you just run the show pressing the space bar.
Well, I was about to say, once all the cues are all programmed and everything's set, the director's happy, everyone's happy. The actual sort of process, agriculture thing.
It depends on the market, but if you go into a West End show now, on any given night, in any given show, you will find a stage manager reading a script and telling somebody else when to press a button that makes the lights change. And the person pressing the button is probably reading a book.
Ready on a cue, then go ready on a cue.
Now, other markets, rock and roll or live music, are completely different.
So how do you become a favourite of the show?
Well,
run through it quickly.
most computer systems now will have a redundant backup. They'll have another, usually identical or like a rack-mounted version of the same console that's tracking this one. So the theory goes that if this one dies for whatever reason, this one will pick up the pieces and carry on. Now that's always slightly suspect because if a piece of software crashes and the other one's doing exactly the same thing, you sort of think maybe it's probably going to do the same thing. So in my world, my personal preference is I have another one there as a hot spare, but it's not plugged in so that it's not doing exactly the same thing at exactly the same moment. And what's interesting now is I used to have to argue the case about paying, because for, again, West End we rent the rig. So if I add another computer, I'm adding cost. And it used to be producers whinged about that. Well, you know, shouldn't it be reliable? Isn't it a computer? Now they insist it has to be there, because if this one fails and they lose a show and there is no backup, their insurance company won't pay out for the lost performance.
The failures are more likely one of the moving lights,
Yeah.
wandering off and pointing over there. And not going
Oh,
anywhere
just
else.
losing
So
his
you need
mind.
one of those to
Yeah, I mean, or the biggest failure I've had lately is the Beautiful, which is a musical in the West End, has just opened. We did a preview show 3 weeks ago, and halfway through Act 1, 2/3 of our rig went out. And that's a real, holy... And the console's running fine, and the console's saying everything is fine. Now, the thing I've sort of glossed over is, the other limitation of the DMX standard is the lights can't answer back. So basically this console is sending out data all the time and assuming that something is there listening. There are protocols now coming where that's beginning to change. But I had no way from the console of knowing whether the lights had lost communication or lost power, except I knew they weren't on anymore. Not being on was a clue, because if they'd just lost data, they would probably have sat there doing whatever they were doing. But they'd all gone off. And I could sort of see that some of them had sort of relaxed into a weird position, which made me think they'd lost power. And what had turned out is that they'd installed some new electrical outlets in the building to feed our mains distribution, and somebody hadn't tightened up a screw properly. And so one of the phases on one of those connectors internally had burnt out. And because we'd lost the phase, all the lights on that phase had gone out. You know, so it wasn't a fault with any of this technology. It was a super low-tech doing the screw up properly problem. But and we had a superstar electrician who was up there trying to rewire things and move things around to get us going enough to let the show carry on. And in fact, we staggered through to the interval. The show looked a bit weird. The follow spots, you know, the human-operated front lights worked much harder than they normally do. Possibly nobody in the audience noticed is the really demoralising part. And then in the interval, we moved some stuff around to let us do Act 2. And then the next day, we came in and fixed it properly.
Questions?
What about moving light control? When did that happen?
You're welcome.
How do we come from that transition to moving light control using DMX protocols for moving light control from...
Well, so originally, the Verilight were completely their own system, entirely proprietary. They made the lights, they made the console, they made everything in between. And if you wanted to use it, you had to sign up to Super Verilight School, because there was a massive patent war going on. But literally, through the 80s, on big gigs, there would be a tent somewhere, which was a secret Verilight world, that you were not allowed in unless you'd signed the non-disclosure agreement and probably done their training. I mean, it was...
You could rent as well.
You could only rent them. But the rent them was an interesting model, because, of course, they weren't very reliable. But as a producer, you didn't care, because what you were renting wasn't the lights. You were renting the package of the lights and the technicians and the console, the person who knew how to work the console. Because that's the thing, because the Artisan, that big Verilight desk, is a keyboard to the lights, you need somebody who knows how to use it. And you got that as part of the package. And those people also help to educate lighting designers who are used to lights that just do this into the possibilities of lights that could do this. It spread because other manufacturers started making moving lights. They got around the Verilight patents by not moving the light, but by taking a light and putting a mirror on the front and moving the mirror, which is a different thing, but achieves sort of the same result. They used DMX as a standard for controlling that, which is a dreadful standard, because it's now up to you to say, okay, well, channel 2 is pan and channel 3 is tilt, and have a big piece of paper somewhere telling you that. And people originally ran that on desks like this, where literally they would have a table and they're saying, channel 1, okay, that's adjusting the pan. Channel 2, now I'm adjusting the tilt. Channel 3, now I'm adjusting cyan. Channel 4, I mean, it's completely bonkers. But then ultimately people came along and started saying, okay, but my console can deal with this better. So this one, which is the one I earned my living on for 15 years from about 1995, was a theatre-style desk. You know, it was a successor in many ways to the exact operating philosophy of that and that and that. But it added on that you could tell it, this light, channel 1, is no longer just an intensity, it's also a VL5, which has pan, tilt, colour, colour, colour. And the set of encoders here then let you control those functions. And then more importantly, they added the behind-the-scenes stuff you need, because you need to be able to not just make a colour, but you need to be able to store it somewhere and give it a name, so you remember that that colour is red. And that came on, you know, this and the Hog2 and other consoles from about 1992 or 93 through to now. And it hasn't really changed very much, I have to say. You know, the MA, which some of you will know, is the same as a Hog 2, except everything's more colourful, really. And it's much more German. I mean, this button here, which adjusts the tilt of the screen, is called push to erect, which is hilariously funny. But they don't get it. But the one that actually is funny is the undo button on this is called oops, which is kind of brilliant. And on the new one, the enter key isn't called enter, it's called please. So you go 1 at 50, please, which is funny. In a German.
I'm going to push you for one last question.
Yeah.
Because time is pressing on, and I have to do some. Haven't you people got homes to go to?
Oh, but there's two.
Now all of a
Look.
sudden there's a rush.
Let's do two quick ones. You go first, you go
What do you
second.
think the future is?
Well, I mean, you know, what the future should be is at the moment the controller with the moving lights has a big problem because it doesn't know anything about where the lights are. Okay, so if you have 100 moving lights and you want to point them all to the guy standing at the front of the stage, you effectively have to do it one light at a time because the desk and the lights between them don't have any spatial awareness about where they are. So you have no way of saying, take those lights and point there. Now, WYSIWYG, the visualization thing, the guys behind that realized that and they built a tool which would do the calculation and hand the data back to the console to do that for you. So now it's amazing because A, you can do it in one click, but also it scales well because if you have 1,000 lights, it's still one click. And they released that protocol freely to the market, which collectively, because the problem is, I mean, there's a thing I skipped over where Martin will tell you what was amazing about these guys at Strand is they were physics graduates and they all came from like crazy backgrounds because Martin used to deal with supercomputers on submarines, which is probably will all get killed now because it's some kind of official Secrets Act thing. But it doesn't scale well. But they released it, and the rest of the they all had some kind of theatre background, even if it was just Amdram. So if you presented them with that kind of problem, they'd understand why it was a problem. Most people now who do most of the software for most of these consoles have no interest in theatre at all. They're just software guys, and that's a problem because they don't understand the problem. But for example, so this was presented to the market, which collectively said we don't understand why that's important, whereas all of the users are going, for fuck's sake. So one prediction could be that if you took all your lights and you put some kind of GPS-y system, except it can't be GPS because it has to work indoors, and they could all figure out where they were, suddenly you have a massive advantage because without doing anything else, you can say, you guys point there. And more importantly, if the next week the rig ends up sitting 6 feet higher, they'd all just figure it out again and the lights would go back to pointing to the same place. Whereas at the moment, if that happens on a tour, I have to manually adjust everything again, which is ridiculous in many ways, but is what we all do. Can we do the super last one?
Last one, very last one.
Say favourite console and why?
Oh, yes.
Well, what I've discovered is everybody, the first one they use in anger for their career is their favourite one. You know, so all the people who grew up on Galaxy will never ever stop talking about Galaxy. I came along just after Galaxy when it transitioned into this, which is the 500 series, which I love to this day because I know it, you know. And the thing I say to students now is, most people who do what I do use one or at most two consoles, and the reason for that is it's the difference between being able to speak schoolboy French, which is where you think of what you want to say and then you sort of figure out the words that you need to do and then you figure out how to say them and it's really slow, and being fluent in French, which actually means you're thinking in French. If you know, everything we're trying to do on this super tight timescale, what's important is that you're the interface from the lighting designer's vision. You know, if you could minority report the console into the lighting designer's brain, my job is redundant. But my job is the interface, and it's an interesting job because I have to have an artistic eye as well as a technical view. But ultimately what I have to be able to do is listen to what he wants and then go, oh, yeah, there you go, how's that? My favourite one is still this one, but that's in some ways because I know it incredibly well, was involved in helping develop some of it, so it does things I know I wanted to do. But, you know, if you ask somebody else who uses another console, they'll say it's that. You know, so that's my answer. Final answer.
Right. I think that's the local sort of, is it the 18th wherever they are?
I thought there was a revolution happening outside.
Official secret.
Rob, thank you very much.